from IBM, and finally concluding with TI. The core discussion topic for all these presentations would be how that particular organization has adopted formal, what have been the challenges in the adoption of formal, and what is the future of formal. So it is centered around formal. You're free to ask questions during the presentations. I would request you to just raise your hands, because there are people logging in via webinar also, so we would want to keep the flow uninterrupted as much as possible. We are already 5 minutes late, so I think I'll just introduce the first speaker for today, Mr. Achyuta Kumar. He is from Intel. He is a staff engineer at Intel. He has graduated from IISc Bangalore, and he has worked on the rather infamous Whitefield project as an RTL designer. He has worked on circuit designs, backend synthesis, basically explored all areas of functional verification before. He runs a team which focuses on, which is actually a center of expertise for formal methods in his group globally. And he also runs a formal focus group for Intel India, which is a common platform for increasing the formal presence in different projects. So Mr. Achyuta Kumar has also worked on multiple multiprocessor cluster level verification designs, and he runs a formal focus group for Intel India. So without much ado, I hand over the mic to Mr. Achyuta Kumar.
Hi, good morning. I go with the name Kiran rather than Achyuta Kumar. So this morning, actually, I had one paper selected on formal methods conference in Singapore, and the EPTCS where you upload those papers, right? That guy was asking, you have so many names. Tell me how would I call you? So my name actually is like Madana Pantala Venkata Achyuta Kiran Kumar. He's asking, which one is your name? So looking at this name, my name is Kiran. You can just call me Kiran. Today I'll be talking about the challenges, the journey through which we went through in getting formal into the graphics domain. So formal has been there at Intel for quite some time. Today I'll be focusing on how we started, and I'll take you through the journey, how we, where are we in the current position in the graphics. So briefly, this will be my agenda. I'll be talking about the brief history of formal at Intel. What was the how we did the POC in graphics and our journey in brief. Some of the experiences, what worked for us, what can be better, and then I'll finally conclude. So as you all know, the way Intel embraced formal was with this FDIV, right? So I hope you all remember what this FDIV bug is. So in June 1994, there was an operation where you multiply two numbers, and when you multiply these and divide by the same number, you get a completely different result. So x into a by a, you will get some x bar, which is not equal to x. So this was posted in public, and there was a mass panic, and there was a big recall, and Intel agrees to replace all these Pentiums with the bug. And it costed 0.7 billion in 2010 dollar equivalent. So what was the problem? If you look at it, if you look at the x by y, there are certain holes which are not being exposed by any of the dynamic, and these are holes which are not existent all throughout, but there are deep holes and big holes at some point where the hardware would behave erroneously. So this was one of the graphs from Larry. It's only in these tiny portions, but this actually caused so many billions of problems for Intel. Okay, so that's when the team, there is a team set up at Intel which started focusing on formal verification. So predominantly it started with verifying the data paths, in the sense how the operations would behave when I do a plus b or a into b in floating point domain or an integer domain, how these things would work. So these guys, there was a team which was set up, and they started working on this. So they were called by a funny name called dragons, because they were in the primitive age. So this team was set up and they started evaluating like how to get formal into this, and they were able to like catch all these bugs and fix it from there. So from then all the cores, they have to go through this formal. So because it has burned the hands, that's when Intel has embraced the formal. From that point onwards, everywhere whenever there is a chip that's taking off, at least the core portion, they make sure that they do a formal on that. And the recent ultimate reality is with the i7 exe execution. So i7 is the which you see the core to duo, the dual core processors which you see almost of your laptops, right? So this is with respect to the paper which was submitted in CAV 2009, and it got the best software award from Microsoft. The principal engineer called Rupe Kaivala is the one who architected this methodology. So I will talk you through like how they did this. So the whole exe cluster, which is the execution cluster, which is the complete data path heavy cluster, it has a couple of control logic also. That was completely done only through formal. There was no damage done on that. It was completely done only through formal. So here the complete data path verification for all FPU and data processing units, the floating point as well as like the address generation unit, the integer units and everything. Whatever there, all the data paths, they were completely verified through the data path verification. And the control path, we have a tool in house, so that does the model checking for those assertion based verification for all the control paths. The other thing what they did is whatever the assumptions that we have in the control path or the data path, these were actually plugged as a control invariants, and they were plugged in the regular regressions, the high level, the full chip level regressions. So if at all there were any problems with any assumptions, those would have caught, luckily. So, but luckily we didn't have, there was only one escape because of one wrong assumption, but as such there were no escapes. A typical processor would have at least 10 to 12 such good, like decent size number of bugs, but in i7 there was only one bug that escaped through the whole verification. So these are like, as I said, that these are plugged in the full chip level. So there are like checks at every level to make sure that we are not missing any holes through the whole operation. So this was what was done by i7, and this gave a lot of it gave a lot of motivation to a lot more groups to try and explore why shouldn't we be using some formal. So that's when our management woke up and said that, okay, why don't you start? Okay, so we started with a team of one, and it was me, and there was another girl who just joined after some time, and we started again with the already proven data path verification, and like continue the rest. So now my team is like seven people strong, but I'll talk you through how we actually went about the journey, because that's what was the topic of interest here. So we started, as I mentioned, we started with the data path formal, and this is through STE. So STE stands for Symbolic Trajectory Evaluation, which is an internal Intel internal tool. So it was designed in conjunction with Carnegie Mellon University and Stanford. So that was a tool based on Forte toolset, which was working on this STE. And through STE, we verified all the data path verification. So let me tell you a small story how we started. So when we started, they said, okay, you are wasting one guy, I'm still okay. Then another girl also started working with me, and we both were like spent almost like 4 months in ramping up on the tool. And the architects as well as the designers as well as the whole validation team, everyone was shouting at the top of their voice, man, we were okay when we wasted one guy. You know he's not so useful. But you are wasting two people, and this two heads typically is a big count for them, right? So you are wasting two people, and you didn't give any ROI. So these guys are, I mean, with a short temperament, right? When they see at a 3-month gap, with a 3-month slot, there is nothing that we gave it back to the group. Second quarter, again nothing. Third quarter, we found reproduced 3 bugs. So they said, so what big deal? Anyway, those are caught. You just reproduced 3 bugs. So at the end of total like 9 months, we have reproduced only 6 bugs on an existing project. But just note that design has been like rigorous for past 3-4 generations, and we were able to only catch one corner case bug which has a workaround. So they said, okay, what big deal? Then luckily what happened is there was a re-architect, the floating point unit was re-architected to give a lot more throughput and all that stuff. So that's when we jumped in and right at the beginning of the project. When the validation environment was still not up, when the DB was not up yet, we had already the proofs which we have developed for the previous projects. We started with those proofs and we found like 286 bugs on there. This accounts to 82% of the total number of bugs found. And the remaining 18% of those bugs are not on the UOPs which we have implemented. These are all on the UOPs which we haven't implemented, which was tough for Formal to hit through, or we were like a little bit late in implementing. So those are the only bugs that we missed. But here, this was the number which woke up everyone and said, okay, Formal does some work. And then now the current situation is the architect or the micro architect, whenever they are designing some implementing a new UOP, they ping us saying that, hey, we are trying to implement this. Do you see any problem here? So that's the kind of credibility which we built from like 0 for 9 months to like within 1.5 years. So now that's the current state of art at Intel graphics. So this was a strong and main tool for finding bugs for all the next generations. After this 286 bugs, we have actually checked on through next 2 generations. We have like 80 bugs and 60 bugs in the next set of generations. And we have increased the gamut of the formal offerings on simple control path design. So yes, when once you have found out these bugs, they wanted to, so the expectation is high. They say, okay, now take some more designs and try to prove something on the formal. So, but the data paths are pretty limited if you look at it. I mean, they're concentrated only on a couple of units. So then we started increasing the formal offerings. Did I press something? So we increased the gamut of the formal offerings. We started with simple control path designs. And again, a story to tell you how we started on those control path designs. So we used to go to these people and say that, you know what, we have certain tools, model checking tools which can catch some bugs. Then let's say, okay, first at least catch this bug which has been caught by the development. So we used to take the buggy model and reproduce the bug for them and then show them how their fixes were complete or incomplete. So that's when we started like gathering a lot more confidence from the designers. So once these guys got bought into the act, so now we have a lot more, everyone says, okay, can we try formal on this? So that's how we started. We started with simple data path, then started expanding on a couple of control path logics, and now we have spread in both and data and control path areas. So that's what we said. Like we started on the simple problems and gained the confidence of the designers. So we have deployed like various standard flows. There are a lot of tool. The thing is that when we started, we had an internal model checking tool which was not that great to take it forward to the next level. Now with the kind of offerings that we have in the formal world, there are a lot of vendors who are giving us a lot of good set of tools. We have increased the gamut to something like scoreboard checkings or like checking the connectivity, checking the CSRs, checking the low power and all that stuff. So we have increased the gamut into a lot more areas now. So from then we started also looking at something which was like pretty simple, the RTL to RTL. So everyone used to ignore, they weren't so confident of this thing, but we deployed these formal applications there to give an example, right? So whenever there are like bugs which are fixed towards the end of your design, right? Typically you are skeptical about the fix that has happened, and you would add a chicken bit to it, right? So we used to make sure that when the chicken bit is disabled, we have the equivalence with the previous design. And believe me, how many chicken bits that we have verified, we have found at least like 1 or 2 issues there. And the other thing is like a couple of timing fixes. So timing fixes should not change your functionality. So whenever there are timing fixes, we go ahead and do an RTL to RTL. And there are, to add, there are a lot more like the clock gating verification and something like the parameterization, something like backward compatibility and all that stuff. So we have increased the area of this RTL to RTL formal verification. And the main advantage of this is it is very simple investment. we have deployed the flows. So now people, we develop the GUIs, flows and everything. So people have to just like click on this. Whenever there is an RTL fix that has been done, non-functional fix, they go and just click the button and they'll get the results so soon. And we have faster and guaranteed results. I'll talk about one point here. There was one fix that was made in the recent past, and they ran a regression of like 20,000 seed, and it passed pretty fine. Then we said, okay, they said, no, we don't want to use RTL because my whole regression is clean. So then we have run this, and it found a very corner case issue. So those guys were like, no bought into it. Whenever they do an RTL change, they'll first simply click the button. So people are lazy even to click a button, right? So that's the kind of thing that we have deployed. We started with control path, then data path, then to control path, and the RTL to RTL, which gave maximum ROI for us. And we have worked on a couple of tools, new tools to get the convergence faster, get such kind of sequential equivalence and all that stuff, and we have deployed those flows. On top of it, we also explored a couple of property generation tools, and we have demonstrated those property generation advantages to the teams. So I know this guy is laughing here. It's like you guys also recently started, right? So the biggest problem with the control path is people say, oh man, what should I write? What are the assumptions that I should code? What are the properties that I should code? What should I check? All these things, right? So there were, so what these property generation tools do is they sit on top of your regression or read all your FSDVs and say, okay, these, I observe these behaviors, and it dumps out all the behaviors. I mean, the common properties which it can think of when looking at the regression, it will dump out all these properties. So it's something like giving a kickstart to all the lazy birds. So we have deployed those tools, and now we are like well poised to actually take lot more units and challenges. Yes.
In fact, the central point of adopting the formal is the success of always you can leverage designer knowledge.
Exactly. Right? Exactly.
So being a formal registration where sometimes I lack that knowledge if I don't work on that particular unit or network.
Right.
So in Intel, how did you take it up and recommendation?
Yeah, good question, because this is the most common challenge which all of us do face day in and day out. Right? So the question was, I mean, how do we motivate the designers, or how do we make them like accomplish an action when we are doing the formal? So how we do, even today we have challenges with a couple of units. So what we typically try to do is we approach their managers, and we tell like what are the advantages that we gain deploying this, get a buy-in from them, put them in a dungeon, make them write all the properties, debugs wherever we have some problems, or we get some ramp ups with respect to those, and then we try to work through them. So it's typically tops down. That always works. You being a manager, you know more of it.
Yeah, actually, one of the issues is, I mean, in order to get that confidence from the team, is the closure part of it. Usually, this is something which is still gray. I don't know. You are the expert here. So we don't have a clear methodology to show it as a metric, and with some metrics that we have covered the complete design through these programs.
Right.
So there are different methodologies I have visited, but it still doesn't give confidence that the design is being covered now.
Good question. It's I think these are one of the most common questions, right? How do I know when I am complete with my formal? So before the advent of certain tools, I don't want to name the tools. There are certain tools which can actually help you with this, which can definitely help you. There are a couple of folks within this room. You can talk to them. They can help you with respect to the kind of tools that you can use to find how much you have completed in your with your exercise. Typically, one of the strong recommendations from Intel is when they say, okay, towards the end, tell me what are the cover points that you have covered. So we sit with the micro architects, we sit with the architects, and we say, okay, so these are all my interesting micro architectural points. Has this been covered through any of my through all these assertions that I have coded? has this been covered, has this been explored, has this, did this guy get a value of these particular values. So we try to write the covers towards the end to make sure that the cover, whether your journey is through or not. Nevertheless, there are certain tools which can actually help you through this. You can explore, not here, I would rather talk to you later, but there are certain tools which can help you out with that. If you would have attended a recent user group presentation, which I can't take the name, in Cadence, there was another tools user group presentation where they had a different methodology to drive a closure. They had to derive certain metrics. Now, sitting in Cadence, I can't talk about their competitors user group. So, on the other hand, what we also did is we worked with a central body of formal methodology deployments at Intel. So there is a group called FVCOE, which is a Formal Validation Center of Expertise. There are like a couple of PhDs, double, triple PhD guys sitting there and only thinking about this. So we worked closely with those central body and we got certain deployments and certain flows which we are deploying, we run it through them, certain proofs, we run it through them. So we like make sure that whatever that we are coding is not just out of the blues, but they have some credibility attached to it. And on top of it, we starting then we shared our experiences and expertise through various technical forums within Intel as well as outside Intel. That's when I got a chance to meet all these folks through paper submissions and technical discussions. So that's how our team from 2 started to 7. So that was our journey, and so I will briefly talk through the successes and failures of FE. So it has a better reachability. The FE is now much better reachable for non-PhD enthusiasts. So people like me who don't have a PhD, who don't understand what the engine really does, but still there are tools which can actually help you out. There are other tools at that level which can help all the non-PhD guys. And we had good mentoring by the experts for new users like me, and now we think we can actually help some of the new users who are coming up. Though we don't claim ourselves to be experts, but we are good enough, equipped enough. So, and we are we got a lot more areas into the formal, and we had better convergence on those areas. But still, the problem is like the barrier is high. We need the right education. So we need to have certain forums where we see, okay, these are the units which could be taken to the formal. This is a design size that could be taken to formal and all this stuff, right? So certain I've been talking to a couple of recently I was talking to another company. Those guys said, you know what, we tried the tool didn't even load my design. So you need to have the right kind of education to see what is the right tool to use and what is the right design to use, right? So and there are like challenges in the pockets to convince the team, which exactly what Sudhakar was mentioning, that FE is like a no second fiddle. It becomes mainstream. And need to penetrate or convince management or UARC or senior designers more. It needs the right education. And we also have certain expectations from FE in the sense like the tools as well as the methodologies. Like see, the main thing that actually helps or deteriorates a deployment is the debug features. If you have good debug features, people will embrace it just like that. If you say, okay, run these 20 scripts to get a counterexample to debug that, sorry, that's going to be like sent out. And we have certain tools which do that. So the other thing is like, if we have something like, this is a wish list. If we have a test bench to an over-constrained environment conversion, yeah, that gives much more kickstart for FE. Yes, there are certain tools which are still not yet to the mark, but I think there should be a lot more research done in this area where it could enable someone to, okay, have a DL environment, just convert it to FE environment. It should not take more than a couple of days. But as of now, here you sit and write, you find. There are. So the other thing is like we need to have something like a faster convergence and shareable property modules, in the sense some people name it as like proof kits or proof accelerators or something like that. So if we have certain things which have been solved, like the AMBABAs or AHBs, which are the PCI protocol, there are a lot of things which have been solved by a lot of you folks. Right? So instead of reinventing the whole wheel, like how you get an IP proof kit and then just verify it and give it out. right? So now, because the world is moving more towards the SOCs, it will help a lot. So tools are getting more user friendly, and it should be more. FE recipe preparation from specification. There are certain tools, but it needs a lot more work. So also the designs are churning faster, so we need faster proving methodologies also. So that's where we need formal to actually scale up to the next level. No, this one is fine. I think I have last one, right? Okay. So some of the PKMs that I would like to share, these are just PKM in Intel's name is like best known methods, like the we call it just BKM. So it got so much imbibed into the blood, so I use it everywhere. So the BKMs are like the common knowledge sharings. So what we think that we should do is like we should start simple and be nimble. So start with a very small block and then prove that yes, FE can do something, and then start like adding more and more to its gamut. Results speak more about the efficiency of formal. The kind of corner case bug that you have caught is more important for only the guy completely understanding the design would appreciate it more. Oh, is this scenario possible? So he will be more impressed, and that's when they will buy it. The quality of the bug matters rather than the quantity of the bugs. So FE, yes, very hardly you get a chance to reproduce like find 286 bugs in a project. But the quality of the bugs are the ones which actually matter, not the quantity. FE is a time-taking solution, but it is a sure shot solution for most of the problems. You need to identify the right unit and right methodology. You are sure to get to achieve success. If we can't achieve all at one time, better divide and conquer. So you can't take a big design and try to say, okay, I want to verify the protocol. Try it in small chunks. Try it here, and then try to stitch it at the next level. If we next one is like FE completion is not a linear function over the time. So most of the times it's a step function. So you might not even converge for a long time. For 1 month you'll be sitting on it. You'll not even get results. The manager will be asking, okay, how much have you complete? You don't have a number to tell. How much have you complete? So you've been like tested. Suddenly you said I'm complete. People won't believe it, right? But that's how it is. Like it's not a linear function. It will take some time, but it will be a step function, and results like just like that you get it after some time. But you need to be patient to at least to reach that level. The other one is like you need to regularly update your management in a perceivable format through the chain so that you understand the progress. This is the biggest challenge which we face because there will be lots of questions asking, okay, tell me how much you complete. Give me some number, which you can't like cook up some numbers. Right? So you have to like at least conceive some idea saying that okay, these many properties have been written, these many things have been explored. This is the percentage of the design that I'm trying to do. This is the bound that I have reached. So you need to give certain things which are perceivable by the management because currently everyone knows about like these are my coverage numbers, these are my regression numbers. So ideally we should get out of those numbers, but unfortunately we are stuck in that spiral, and you again have to like conform to that spiral and try to match somewhere. So you better have some methodology to share something so that the management understands this. Last but not the least, you need the management will. Right? So as I told my experience, right? So there had been a constant pressure on the management saying, okay, man, why are you wasting 2 people? So finally the management said, okay, we will wait for it, and after like 1 year we will deliver such spectacular results. Now the management didn't have to answer, but for those 1 year we needed that support. And if you are starting something new formal on any of your designs, you need to be patient, and it takes some time. So this is my conclusion. So if you have any questions,
yeah. So one of the prime issues also the efficiency of the process. How efficient are we? So
right. We have something called a library of all the sessions. So even if you are trying to suppose if you are meandering your way, not conforming to the library ways, right? So this library puts you into the groove. We have a strong library which has been shared by the FPCOE. But apart from that, if you think that your assertion is not complete and all that stuff, right? So as I was mentioning, there are certain tools which will actually help you how good is your properties and how much efficient you are covering your properties. I mean, how much efficiently you are covering your design through your properties. There are certain tools that can help you out.
So my question is actually comparing the formal with the functional. Okay. With your experience, do you hold any of the functional verification flow is within this if we are doing both formal and functional verification? So we can say actually we can remove some part of the functional verification and just get back to the formal.
Exactly.
So it's like actually we all know actually formal verification is not the replacement for the functional verification. So we need to do both of them, right? So with your experience.
Right. So yeah, yes and no. Like the example that I've taken about the formal FPU unit, right? So after we have deployed our flow, the SDE flow, and we have verified that for those UOPs are not run through any dynamic validation. We give 100% guarantee. We told our managers you can actually hold our neck if you find any bug in that. And there are certain areas, something like something on the arbiters and all that stuff, right? So where you are not completely sure, it is something like adding formal adds on top of your functional. But there are certain things where certain areas, mostly the data path areas, when you have completely verified through the formal, you seriously don't need any other dynamic validation to run through it. So that with my experience, I would say any data paths, if you have completely verified through your formal, it would be redundant to run any dynamic. But control paths, because we are still not so confident, we will still continue that.
The point you mentioned here is regular approach to management in a perceivable format. So you elaborated on this point. Any management in a presentation would require pie charts, graphs, or probability curves. Which again you draw the graph using metrics that you collect after you do a SP or a DBA or whatever. Now whatever points you mentioned, try to explain to the manager that you hit this boundary points or they may not be able to take that.
Exactly.
They would still want to extract a figure out of it.
Right.
Now what exactly, in a perceivable format, what exactly do you mean? I mean, they simply don't want to listen. They want graphs and all that you wrote 286 test cases, you wrote that. Now nobody wants all that.
Right. Right.
They want to listen to this quality, bugs, and maybe some amount of some bucket of bugs which may not be of such a high quality.
Right.
Eventually, all that has to get visibility on the graph.
Right. So that's when we asked our management to stop only tracing through the graphs. Actually, one of our managers is also there behind you. So we told them stop looking at the graphs, at least for formal. Give us the time. We have another Excel sheet maintenance. There was another tool developed by our experts where we use the tool to give certain numbers, like how much percentage we are complete. So which is like an IP from Intel. So I couldn't share that Excel sheet, but there are certain methodologies which have been used by these experts, and we try to fit into those and tell that, yeah, we are like this is our progress. With respect to the control path, we still data path, yes, that's the Excel sheet which we are talking about. On the control path, we don't have these metrics. There are certain tools which we are trying to deploy. Those tools would be able to give all the Excel sheets and the numbers and the graphs, everything. They can feed into those. But currently, we say, yeah, this is the bond and this is what it is. And we ask them specifically to help us to make sure that we are not fitted into any of these graphs. We took a disclaimer for that.
So your initial formal methods are something that you start from market available formal methods and try to build on that, or you have your own indigenous formal methods?
So there are certain methods which are like completely indigenous, and there are some other areas where we start with the market. So there are a lot of tools for example, on a model checking, where we stopped using our indigenous tools. We started using the we started using the market tools. I can't name the tools, but yeah, we started using those tools. Not only in these areas, we started like expand. So the principle for us is simple. I mean, if our tools are stronger than a market tools, we take only our tools. Even if it is the market tools are even slightly better, we try to improve upon our local tools. But if something like the market tools offer you much better benefits than the local ones, simply we shift to that.
The local tools would not have gone through the kind of quality checks that a licensed market, available tools would have gone through.
Not necessarily.
They would have been regressed on various customer designs.
Intel has.
Your own internal tools might have been regressed over a longer period, but with your own design.
Yeah, so our designs are like completely varied, right? Starting from the servers, cores, graphics, to SOCs, to chipsets. We have every offering what the external industry uses. So we don't need an external industry to qualify our tools. So at least our guys claim that the ST is still the strongest tool available on the earth for data part. I don't know about the sixth sense though, but it's true.
The auto properties and everything you mentioned. So how do you assess the quality of the adjustments you generate by this method?
Right. Good question.
Or are you as per your
Good question. So what we do is typically whenever these assertions are generated, so most of these tools they have their own ranking methodologies. So we pick up the top ranks and then sit with the micro architects and designers. We have a dungeon for reviews. First we filter ourselves and then we take it to the designers. Then we sit and like look at it and say that okay, I mean, because this is the only thing what it can give is based on the regression results. There might be something more to it, right? It's an over-constrained environment. That's what you will get at the end of the day. So we will try to like expand it to the right sense. See, nevertheless, we can't avoid reviews. Reviews are the best. Maybe you are using the wrong tool. Yeah, I mean there are like 2-3 such tools. Yeah, but there are certain tools which can actually generate real good properties, which are readable, human readable. Right. SPS. SPS. Yeah.
And you said that you are now applying SE only for the floating point.
No. We started with floating point. We expanded to a lot more areas.
No, that's fine.
Right.
I'm just asking that for the floating point, the control path verification is also being done totally in machine.
Right.
So how, I mean, are you able to get full proofs for that? For the sequences of instructions, pipelining.
No, you're talking about the instruction control path. No, the control path. Partially we are doing it, but not completely. So that's only the i7 project which had a big 15-member formal validation team which could achieve that rate. So our team, we are still like limited, right? So with the limited resources, what can be done, we have done.
There is no protocol involved in that design. So they want to constrain the patterns how do you generate the protocol constraints?
They are pretty easy. Yeah. You can actually give a set of something like at the interface if you want certain kind of things, let's say rec, and after that you get a result after some n number of cycles which you want to try the tool to generate. It can actually take the template and generate your properties. Right. So it's, I don't think you will be able to like completely generate all the assertions. At least it will give you a head start. Okay, I'll be here so we can have discussion even after this. Thanks for giving me this opportunity. I'd also like to thank my team member Aarti, Mayur who are all here. So these are all former team members. Thank you very much.